Today, we're diving into one of the biggest, most frustrating headaches in AI. It's absolutely terrible memory. But we're also going to look at a new, kind of brilliant approach that could give AI a memory that is, for all practical purposes, infinite. Let's get into recursive language models. All right, so let's start with something you've definitely felt before. You're in a deep conversation with an AI, right? You're mapping out a huge project, summarizing a long document, and then, all of a sudden, it has no idea what you were talking about 5 minutes ago. It's just gone. So why does that happen?
Well, the culprit has a name. It's called the context window. The easiest way to think about it is just as the AI's short-term memory. It's a hard, non-negotiable limit on how much text, how many words or tokens the model can look at any one time. And the moment your conversation or your document gets longer than that window, the AI just starts to drop stuff from the beginning. It's kind of like you're talking on a conveyor belt. As new words get added to the front, the old ones just fall right off the back end.
Now, this isn't just, a small bug. It's a massive, fundamental wall that's stopping AI from doing what we really want it to do. And this whole issue has a name. Researchers have a great term for it: context rot. And this quote from the source paper really nails it. It's not just that the AI forgets things. Its entire performance just falls apart as the context gets longer. It starts making weird mistakes, it gets confused, it basically loses the plot. And this right here, this is what context rot looks like. We're looking at a top-of-the-line model, a hypothetical GPT-5, just completely failing at a complex task. That final answer in pink, totally wrong. Why? Because the input was just too long for it to handle. That's a performance collapse, right there in front of you. So here's why this is such a huge deal. This memory limit makes it practically impossible for AI to handle the really big, meaty challenges, what researchers call long-horizon tasks. We're talking about things like analyzing a gigantic codebase or summarizing an entire series of books. We're digging for insights in millions of medical records. Right now, that's off the table. But what if we've been trying to solve this problem in completely the wrong way? Let's meet the solution that this research proposes: recursive language models. The big idea here is a complete pivot in strategy. For years, the goal has been brute force, just build a bigger and bigger and bigger short-term memory. But this new idea asks, what if, instead of building a bigger bucket, we just teach the AI to be way more clever with the bucket it already has? And that is the magic of recursive language models, or RLMs. Instead of trying to shove a whole novel into the AI's tiny short-term memory, the RLM treats that novel like an external world. It's no longer a thing to remember, it's now a place to explore. Okay, so how on earth does an AI explore a text instead of just reading it? This is where it gets really, really cool. So let's walk through this diagram. On the left, the RLM gets a massive prompt, say a huge book. It doesn't even try to read it. Instead, it loads that book into a little coding sandbox. Then it starts writing its own little computer programs to poke around in the text. And here's the crazy part. Over on the right, it makes recursive calls. That just means it breaks the one big question down into a bunch of smaller, easier questions that it then asks itself about tiny little pieces of the book. Let's just break that down really simply. Step 1, the whole giant document gets offloaded into a coding environment, out of the AI's main memory. Step 2, the AI writes its own code to look around, searching for a specific word or jumping to a certain chapter. Step 3, it gives itself these little mini missions on small, easy-to-handle chunks of the text. And finally, step 4, it takes all the answers from its little mini missions and stitches them together to create the final, complete answer. And what is so cool is that you can literally see the AI's thought process right here in the code it writes. In that first panel, it's searching for keywords. In the second one, it's setting up the system to ask itself those smaller questions. And in the last one, it's gathering up all those little answers to build the big one. It's basically using code as its scratch pad to solve the problem one little piece at a time. Okay, so this all sounds very clever, very neat in theory, but does it actually work? Let's get to the results because, and I'm not exaggerating here, they are absolutely stunning. This right here is the money shot. On the left, that's the base model, failing the task miserably, just like we saw before. But on the right, that is the exact same model, just with the RLM strategy layered on top. And it nails the answer.
What this proves is that the RLM method lets the AI keep its performance high even when the task is 10 or even 100 times bigger than its memory was ever designed for. The difference is, it's night and day. We're talking about an AI that can now effectively process information that is up to 2 orders of magnitude. That's 100 times bigger than its original limit. And let's put some hard numbers on that. On this really tough reasoning task called BrowseConf Plus, the normal state-of-the-art model scored, wait for it, 0. A flat 0%. The RLM version, over 91%. And on another super dense task, the base model again got pretty much nothing, while the RLM version scored a very solid 58%. Let's just stare at this one number for a second. 91.33%. This is on a task so complex, so massive, that the original best-in-class model was completely and utterly useless. This isn't just a simple improvement. This is a brand new skill just popping into existence. And here is the real kicker. You'd think, okay, this incredible new superpower has got to be insanely expensive to run, right? Nope. This chart shows that the typical cost of using an RLM is actually cheaper than other methods for handling long documents. Why? Because it's smart. It only looks at the tiny bits of text it actually needs, instead of wastefully processing the whole thing. So, let's pull back and think about the big picture here. What does a breakthrough like this actually mean for where AI is going? So what's the takeaway here? Well, for one, this RLM approach pretty much solves context rot. It lets an AI reason over huge data sets. And get this, it works on the models we already have, no expensive retraining needed. This unlocks a whole new category of complex, real-world problems that until now were basically impossible for AI to even touch. What we're really talking about here is a whole new direction for making AI better. For years, the game has been bigger is better, just make bigger models. This opens up a new path, making models smarter in how they think and how they use information. And that leaves us with one last kind of mind-bending question. For the first time, we can actually start to imagine an AI that has a functionally infinite memory. And if that's where we're headed, what are the really big, impossible problems that we should ask it to solve first?